Hello everyone. Hello everyone. In this video, I'm going to show you a bit example for the center of mass problem. Okay, and this example comes from textbook 9.4, and mm, I just slightly changed the problem. And in textbook, they use the elephant as a problem, but elephant working on a car, working on a truck. But right now, I just switch. Just make it simpler. A man working on a car. Okay, suppose that we have a frictionless surface, and a man is right now is standing on the car and is standing at the left end of the car, and then he start to move from the left end to the right end. Okay, and as the man move from the left hand to the right end, and the car will move to the left. Okay, just like very similar to momentum conservation. The car move to the left, and the problem want to ask you how far does the car move, and the information is 70 kilogram. 70 kilogram. The car is 150 kilogram. The length of the car is 20 meter. And initially, the man and the car are at rest. Okay, initially. Okay. And so when the man and the car initially at rest, so it tells you something. Okay. Okay, the main couples at rest initially. So, what's the velocity of center of mass initially? You all know how to calculate the velocity, center of mass velocity. So, it's capital N and summation alpha, alpha, b alpha, right? So we have two objects right now. We have man in the car, okay, and the total is mass total is n car plus n man. And so M car initially at rest and M man starting at the rest. Okay, so actually easy to get it is a zero. So the initial velocity of center of mass is zero. Okay, and in the previous video I said, if the center of mass, the velocity of center of mass is zero and without external force. Without external force. Okay, no external force. This what will this tell you? This tell you the center of mass, the center of mass doesn't move. Okay, delta R equal to zero. Okay, and the delta R still may equal to zero. That will give you a what equation? What kind of equation? Do you remember that? Because the delta RCOM, okay, the displacement vector of delta COM, and I showed in the previous video, is 1 over m, and the summation alpha m alpha and delta r alpha. Okay, so this is zero, right? No, left hand side this is zero because central mass doesn't go under this condition. So this will give you the summation alpha m alpha delta r alpha equal to zero. Okay, and for our this particular problem, it will give you the equation like this. Man, okay, and the displacement vector of the man plus m car times displacement vector of the car is equal to zero. Okay, and we will use this equation to solve the problem. And the problem want to find out that how far does the car move. So this we are going to after. Okay, so we have to replace this term. Okay, we have to find a relation find a relation between the delta R man and delta R car. Okay, we're to find out the relationship between them because we want to solve the delta, how the car move, how far does the car move, and delta man we have to replace it with by delta car, or this equation is not solvable because we have two unknowns per one equation. Okay, so we have to reduce the unknowns. Okay, so the problem here, so the most difficult part of this problem is find the relationship between the delta man and delta car. I think that's the most difficult part of this problem. Okay, so let me copy this. Okay, wait a minute. Let me copy this. To solve this, solve it, you need to set up a coordinate. Yeah, once again, coordinate. Yeah, coordinate is very important. Yeah, especially you have dealing with some vectors. That's very important. Okay, so the dealing with a vector problem. Okay, first of all, let's set the origin. Okay, because coordinate with a set of coordinate, first of all, you have to set the origin. Where is the origin? Let me see. Oh, ah, let me say the origin. Let's set origin here. It's the left hand side, the left hand of the car initial position. So this I need to change this color. Why doesn't change the color? Something wrong. Okay, so this is the origin. This is the origin. This is the origin. Okay, so first of all, what's the delta R? What's the position displacement vector for the car? Or the displacement vector for the okay, because from this graph, what's the displacement vector for the vector for the name? Displacement is just care about your initial position and final position, right? Yeah, do you remember that? Displacement, displacement, placement, displacement. Displacement vector is equal to final position minus initial position. Okay, you only take care about your final position and initial position, right? Okay, so the man, this is the initial position, and this is the final position. Okay, the final position, so from initial position to the final position. So this is the delta because right now it's the x direction, so it's a one-dimensional motion. So let's just use the x, this delta x man. Okay, and what is the displacement vector for the car? Okay, so we just use this the left end as the reference. So the car moving to the left, this is initial position of the car. Here's the initial position of the car, and here's the final position of the car. So what is the displacement vector? Okay, displacement vector is here. Displacement vector is here. So this delta x car. Okay. And just go back to this problem. I want to find the relation between the displacement vector of the man in the car. Okay. So from this graph, can we find a relationship between the delta x car and delta x man? Okay. Actually, it's kind of very difficult. Okay, to see it. Okay, so we just let's review. We have to do the review things. Do you remember the additional vector? Tailhead, tailhead, tailhead. Okay, suppose we start from the origin here. Okay, with origin here. Okay, and I move to the left. I move to the left. This is called move to the left. Okay, this is called delta x car. Okay, and this is tail, and this is head, and then add the vector 20 to the right, and the vector 20 to the right, 20 to 20 to the right. So on the right, I think it's fine. That's uni vector. Why is 20? Because the 20 is the length of the car. Okay, and that's just description the problem. The length of the car is 20 meters. Okay, okay. So and what is tail here? Tail and this is head. Okay, this tail head and add a tail head, and what's the resulting vector? This vector addition, what's the resulting vector? Can you think about this? Okay, what's the resulting vector? This vector delta xr moving to the left and add the 20 to the right. Okay, what's the resulting factor? Tail, head, and final result is tail, head. Okay, this is the resulting vector. This is resulting vector. This resulting vector is delta x car. Okay, let me look more very specifically. If we use the unit vector representation, it's delta x car I. Yeah, moving to a left. So it's moving to a left, so it's a negative sign. I and plus 20 I. This is the resulting vector, this purple vector. This purple vector is equal to minus delta x cross I plus 20 I. Okay, this is a vector addition. Okay, don't forget about this. Okay, so if you can figure out this, so what's the relationship between the delta x man and delta x car? Hmm, I hope you can figure this out. So okay, so we have delta minus delta x car I plus 20I equal to delta x main I. Okay, that's a relationship between the delta x car and delta x main. And then we can put this back into this equation and we can solve the delta car out. But be very careful. We still have some vector issue here. Okay, be careful. Okay, I'll show you. Okay, so we put everything here in the equation. So delta x man, okay, delta x man, okay, delta main x man I is equal to 20 minus delta x car I plus 20 I. Okay, so actually in x or x direction and plus in car. In the delta x car is here is be careful. It's be careful. It's minus delta x car equal to 0. Okay, be careful because delta here we have the because in under this coordinate the displacement vector of the car is minus delta x car I. Okay, because we set the origin here. So if this vector is delta minus delta x r I. This sign, negative sign means the direction. So be very careful. If you miss this negative sign, you will get the wrong answer. Okay, so this vector calculation is so annoying. That's the very annoying problem. Really doing vectors. Okay, so and we can so we'll have this minus m man plus m car delta x car and I, yeah, and plus m man and times 20 I, okay, equal to 0. Okay, so what we have the M-man. So M-man and M-car is minus, man is 70 kilogram, car is 150, I remember. So delta X car I plus man is 70 kilogram, 70 kilogram, and delta X car. Oh, what? Oh, what? Oh, M-man. Oh, okay, times 20. Okay, times 20 here. Times 20 I, okay, equal to 0. Okay, okay, delta, okay, so the sign convention is annoying. 120 delta x car equal to times 20 Right, so delta XR car is 1400. Okay, so the amount is okay. Let me see. Calculator 140. Let me see. 140 divided by 22. 6 1 2 80.3 something. Okay, what's 6? Yes, 6. Mm, oh, yeah, it's about 6.36 nth meter. Okay, so the amount, okay, the magnitude of delta x car is 6.63 meter. Okay, 6.36 meter, and its direction is moving to the left, moving to the left. Okay, so if you vector, so it's moving to the left. Okay, so I should press this. Okay, moves to the left. Okay, okay, so that's a center of mass problem. Okay, typical center of mass problem. But this is for yeah, this is lots of problem in your similar problem. And maybe in your high school in your homework. Okay, this is a very typical problem in high school. Okay. In high school, there's very bizarre problem. It's more difficult than this. And right now, we just have the one man walking from left to the right. Maybe in high school, I think you might you might practice some problem. Okay, there's a both end they have men. There's two men on the car, and then you have different mass, and then they switch the position. Okay, and after they switch the position, how far does the car move? Okay, right now just only one person. But in high school, you must calculate this: two men on the car and switch the position, walking and switch the position. How far does the car move? Okay, that would be more difficult. But in that problem, it's just split the problem. Left move to the right, get a delta x, and the right move to the left also get a delta x and add them together. I think that's in my memory. I think that's the calculation. Okay, we are two men walking on the car. Okay, but we don't do that difficult example here. Okay, we are just one man moving from left to right. Okay. So, okay, the difficulty of this problem is this: you have to find relationship for these two vectors, and the sign convention is very important. You miss the sign here, yeah, you also didn't you won't get the right answer. Okay, and it's really annoying for the vector calculations. Okay, so this example of 9.4, I hope you can get more understanding the problem. Okay, see you in another video. Bye bye. Okay, maybe just stop here. Yeah, I will just stop. Yeah, and yeah, I will just stop here. Okay, see you. Bye bye. Oh, so long.